Okay, you are not responsible for being able to finish this problem. You should, however, recognize that we should try completing the square here. But then we should realize this doesn't match any of our well-known antiderivative formulas for the inverse trig functions. So at this point you can stop, but I'm going to go very quickly. I'm not going to explain things in depth here because we're going to cover it after the exam. But to do this problem, we do what's called a trig substitution. So we would recognize that we've got sides of a right triangle here in green and blue. And we'd build our right triangle in terms of y, and we're going to make substitutions so that this entire radicand becomes an expression of y dy. So to do that, we'll do secant of y as hypotenuse over the adjacent. We're going to find the substitution for the numerator. So we'll do d dx of both sides, and dx is therefore 6 secant tangent dy. So we have a substitution for the entire numerator. Now we just need a substitution for the denominator. Well, it's not hard to see. Tangent of y is our denominator over 6. Therefore, our denominator will equal 6 tangent of y. Or in other words, tangent of y was opposite over adjacent, so our denominator is 6 tangent of y. All right, with those two things, we can now do the trig substitution. And our dx is now in the numerator. Our denominator is equal to, you can see, 6 tangent of y. The 6's cancel out, the tangents cancel out, and we have just a nice simple secant radicand, secant of y dy. That is a formula we should have memorized. If you don't have it memorized yet, work on that. It's the natural log of the absolute value of secant of y plus tangent of y. Well, we can just go right back to our right triangle here, and secant of y is x plus 6 over 6, and tangent of y is the root over 6. And then we can combine with our common denominators, and then we can apply the rule that the natural log of a quotient is the difference of the natural logs, so the natural log of the numerator minus the natural log of the denominator. Don't forget the plus c, and then this is a constant, so we can combine our constants into one constant, and that's how we arrive at the answer.